Good morning and welcome to another Hidden Gems screencast. My name is Arden Thomas. I'm the Cincom Smalltalk Product Manager. Today's screencast is called Short and Simple. Now the Hidden Gems screencasts, as you know, I try to highlight useful tips for using Cincom Smalltalk, often for things that may not be obvious, thus the name Hidden Gems. So today's tips, I think you really want to know about and use if you don't know about them already. One thing Smalltalk is great about is readability. The ability to write code that's simple, clear, and communicates very clearly what it does. By having less code, you have less code to maintain. It's easier to understand and change, and it lowers the overall costs of your application, and also it's more enjoyable to work with. So recently we've had some clever improvements that leverage the power of polymorphism to make things even a little simpler and a little clearer for things that are used frequently. A first example is iterators. Now iterators are used very frequently. Here's an example of going through a collection and rejecting every one that's nil. We can make that a little simpler and clearer by just saying is nil, but there's some new ways that I'd like you to know about. Here you can simply, rather than giving a block, you can give a symbol that basically is the symbol of the message that you want performed for each item in the collection. So how does it do that? Well, actually, let's take a look into that. We have ABC nil, and we're saying reject is nil. Let's debug that. And if we walk into here, what we'll see is that the symbol itself understands value colon and tells it to perform. So essentially what that is going to do is tell the symbol to perform is nil. So it sends it the message is nil, which returns, in this case, false. Let's take a look at the results of that. And of course we get ABC because it rejected the nil. So it works as we expected. It's shorter, it's simpler. And this technique works for most of the iterators for most of the collections. In general, where you're sending one message in that block, so it won't necessarily work for compound or complex things, but for simple things, it can make them very clear and terse. Here's a couple more examples. Say you have a collection of customers and you want to get the name of each customer. You can collect the customer name with this simple example. So again, it removes the block and all that syntax and makes it very, very simple and terse. You can do things like select, so you can select all the customers that have an outstanding balance, for example. And again, this makes things very, very clear and simple. Another example that I want to show you is for sorting. Now here's a typical sort. Say again, we go back to our customer example, and we want the customers sorted by last name. Here's an example. They're sorted in ascending order by the last name of the customer. So we can do a similar kind of thing to the iterator example we saw, where you can simply say sort by the last name ascending. Now the way it works here is if I inspect the result of this, it's a sort function. So it's a sort function that it's sending to sort, which basically allows us to do this with a terser syntax. And again, this simply leverages the ability of Smalltalk to do polymorphism. Okay, another example for sorting, and here's maybe even more useful in that this is a more complex example. It's basically a subsort. So this sorts all the customers by their last name, but for customers who have the same last name, it does a subsort by their first name. Okay, and there's an example of how we can simplify this as well. And let's take a look at that. Okay, last name ascending, comma, first name ascending. And we would see that let's take a look here. If I inspect this, it's a sort function. If I go to the sort function, I can see that sort function understands the message, comma, binary message, with another sort function. So that's essentially what's happening here. We're creating a sort function with another sort function, and what that looks like, let's inspect that, is a chained sort function. So this is a way to basically do that subsort, last name, and where last name is equal, then it subsorts by first name ascending. So I hope you found those useful. 2 examples: iterators, where we can simply send a symbol for lots of iterators, and sorting, where we can basically use this syntax here to do simple sorts and subsorts to make things simpler and clearer. Again, this is Hidden Gems Short and Simple Screencast. If you have ideas or examples that you'd like me to highlight here, or you have any questions or comments about the screencast, please contact me at athomas@cincom.com. Until next time, have a great day small talking. Thank you.